Right then, good morning everybody. My name is Matthew Parry. We already had a bit of an introduction from just then. I'm the Technical Sales Manager for South Western Wales for Tarmac. And this is Andy Hodgkinson, Technical Product Support Manager for the Midlands at Tarmac. So first of all, Tarmac at a glance. Most people probably know who we are and what we do, but it's a few facts and figures. With 6,000 people employed by Tarmac, and we're number one supplier of construction materials, sustainable materials, plus the other facts and figures below. So the 6,000 people in Tarmac share a company-wide commitment to decarbonisation. We've got a clearly defined carbon reduction plan, which we've set out in our Act 2030 sustainability strategy. The ultimate aim is to reach net zero by 2050. We've done this by exploring site energy self-sufficiency using microgrids on renewable power sources, the use of transition fuels such as HVO, and engaging with our supply chain on their carbon reduction initiatives. As most of you probably know, in the local authorities, over 300 local authorities declared climate emergencies back in 2019, committing to net zero targets. Some of the key drivers to sustainability include the use of low carbon materials, which we're going to talk a little around a bit later on this presentation, reducing waste, incorporating recycled materials into our operations, and extending pavement life. So there are multiple opportunities for CO2 to enter the production and delivery process with asphalt. So on the left-hand side there, you have mineral extraction and distillation of crude oil. Moving further on, you have constituent materials that need to be delivered to the point of manufacture. Once they're at the point of manufacture, you've got the heating and drying process with the aggregates, and also the heated storage of bitumen. And then further to that, you've actually got the CO2 costs involved in actually mixing those two products together, the bitumen and the aggregate. The finished product then needs to be delivered to site where it's required. And once you get to site, you've got plant, you've got machinery. This also has an impact on the CO2 in the process. Plus, you've also got the labour force on site. They've got to get to and from site, to and from their place of work. All of these things start to contribute to sort of build up CO2 on a project. But with all these factors combined, what levers can we pull to mitigate carbon input? Kind of talking a little around circular economy now. You may or may not know what it is. So just, maybe teach me granny how to suck eggs. It's basically the reuse and repurpose where we can at the end of the material's life, rather than sending it to landfill or other means. Reduction of natural resources, reduction in carbon footprint, reduction of waste to landfill, as mentioned before, and fewer maintenance interventions, to name a few, so longer lasting materials. So up on screen here, we've got a few of the levers that we can pull. One of these is RAP. RAP is a key component of the circular economy. It stands for Reclaimed Asphalt Planings. Current standards allow for up to 50% RAP input into certain mixes. This percentage has already been achieved on one of the UK's busiest motorways, on the M25. But there is scope for the boundaries of RAP input to be pushed even further in the future. Depending on the RAP percentage and mix, a 20% carbon reduction is possible just through RAP addition alone. And the sheer amount of bitumen-bound material on UK roads and its potential for reuse makes our road network the potential quarry of the future. Matt just spoke a little around the circularity there. We're talking about actual carbon reductions. Warm mix asphalts are readily available, have been for the past 10, 15 years. We start seeing adoption of those. Warm mix asphalt offers up to 15% reduction depending on mix in carbon dioxide emissions, typically around 8 to 10% though. Warm mix asphalts also offer proven gains in productivity. So it essentially requiring less time to reach trafficking temperatures, and therefore can be done at an increased rate and in a single shift. National Highways estimates
that an increase in shift outputs of 20% could be provided by using warm mix asphalts on its network, which it currently does. So that's a massive improvement. So the lower asphalt temperature also reduces fumes and steam on site, increasing the health and safety benefit.
Another initiative we're on with is biogenic asphalts. So working with our supply partners, Tarmac are developing and testing a new generation of low carbon, biogenic and long life asphalts. So this technology will help to reduce carbon footprints, capture carbon and embed it within the road itself, and significantly extend pavement life compared to current materials. Available data suggests that biogenic asphalt technology using plant-based binders could reduce the carbon footprint of a typical asphalt mix by approximately 40%.
So a great case study here. Tarmac was challenged by National Highways to resurface the A64 at Branham, just north of Leeds. And the key initiatives being, and what they wanted to achieve, was a low carbon construction emission, near net zero, extended pavement life, which could reduce carbon through reduced maintenance interventions, smoother roads, which meant less tyre rolling resistance. So again, you know, they're all initiatives that wanted to be achieved.
So the question is, what do we actually achieve? Well, National Highways sets a target of 70%, and on completion and evaluation, we managed to achieve an overall carbon reduction of 75%. This was achieved without carbon offsetting and was calculated on material choice, delivery vehicles used, and installation methods. We also hit the National Highways prescribed mandate for a smooth surface, so the overall IRI of the project was 0.9. And our next slide is going to contain a short video to give you a little bit more info on the project.
That's again. Will it play?
And again.
Yeah, so you see what we achieved on that side. You know, it was the art of the possible, what we kind of marketed it as. So another initiative to kind of reduce carbon, be more sustainable, is the use of single layer materials. So that they are non-standard, but these can offer less material usage and up to 15% CO2 per square metre reduction. So that's based on 1,000 square metres, a 40-60 split of 10 mil SMA surface course and 60 mil binder course versus 70 mil ulti-pave single layer, for instance.
But the solution is challenging roads. Making the right choice of material is particularly important on challenging roads that are subject to repeated cracking because of underlying movements in the pavement. This can include evolved roads in areas with clay soils subject to seasonal expansion, and roads based on jointed concrete that can be subject to thermal and traffic-induced movement. By adopting a whole life approach, investing in better materials, highways engineers can break the cycle of repeated deterioration and running repairs, which can be costly in terms of maintenance budgets and carbon emissions.
A great example of the most of the challenges Matt just mentioned is right here in Warwickshire. problematic road at New Road, Oldminster, suffered from major cracking and had been resurfaced very regularly, costing the local authority a lot of money. 2 sections of the road were surfaced as a head-to-head trial, one a 10mm 55% HRA and the other an ulti-layer proprietary mix from Tarmac. As a result, we saw earlier failure of the HRA as expected, while the ulti-layer remains crack-free 14 years after install. So again, the whole life costing of that really paid dividends for the local authority. Another great example of the sustainability through durability is this example of a heavy route through Malvern Town centre in Worcestershire. Concrete overlay are renowned to be problematic for reflective cracking, and overlaid with with asphalt. So the site was laid using the ulti-layer Samir material with an ulti-layer 10mm for the surface course, and it remains crack-free after 10 years.
So what we've got to ask ourselves is, are we making the right choices when specifying asphalt? The temptation is there to reduce initial embodied carbon, and it can override the whole life carbon cost consideration. Sustainability through durability is key, and picking the right material for the job, even if the initial carbon cost is slightly higher, will pay dividends over the life of the project. So sometimes innovation requires the bravery to challenge existing standards when using new or unconventional materials. And consistency in these challenges and proof of performance will eventually lead to market acceptance.
Following on from Matt's point, in response to our customers' requests for guidance on the right materials, a lot of people can get bamboozled because there's that many materials out there, and the right scheme for the right outcome. A treatment matrix was produced as a comprehensive smart material selection document, depending on road type, challenges, surfacing options, surface cost recommendations, and base and binder if required, and also an indicative carbon saving and a cost benefit analysis as well.
So Tarmac is not just limited to its materials when it comes to carbon reduction initiatives. Our national contracting teams can also provide solutions as well. So on the wheel on the left-hand side there, you can see a bit around machine control. So no manual or human intervention involved. Multiplex milling, which uses an averaging beam. So it levels, it creates a plane effect with the ability to remove high spots. Mill assist controls both the travel and drum speed of the planer. We can also use LiDAR as well, which is like a laser scanning of the ground. It scans the surface to millimetre precision and identifies any deviations or bumps. Feeders as well can also be used, and that provides you with a continuous uninterrupted flow of material and reduces the potential for joints or poor joints. Averaging beams enhance the smoothness of the paved material by taking levels in advance of the paver, and also BPO and thermal imaging, which also give a visual indication of any temperature variation in the pavement.
The interesting thing on the Bramham scheme, basically the IRI level been really low. So if you have a road that looks like this slide here, lots of energy is spent moving the vehicle up and down. So the important figure to note on this slide is a 7% reduction in fuel consumption going forward after the road is laid is possible, and that's from a Danish paper. By achieving smoother surfaces. We have had the calculation back from the A64. I don't know what that looks like at the moment, but come and talk to us. We may be able to share that information.
So, in addition to the A64 project at Bramham, we've also worked closely with Hartlepool and Stockton to achieve an 83% reduction on their road network. If there is interest in that, there is an 8-minute mini documentary titled The Art of the Possible, available on YouTube if you'd like to know more info on that project. But we've already proven the concept and delivered carbon reductions against defined targets. Our question to you is, what's your next project? Work with us and we can reach our carbon reduction goals together.
Thank you very much. I'd like to open up a short Q&A. Otherwise, if you'd like to come and speak to us, we're on stand 45. Be more than happy to speak to you. Thank you.
Just for the others. Thanks for your time.
Thanks, guys. Are we any immediate questions now? Are we okay? No, good. I'll catch up with the guys after. I've got a couple. We've got a bit of time. Quick on the spot. So you mentioned biogenics in there, and that's the things like lignin and what? Yeah, is it now? How much of a spot in the marketplace is that currently? How often do you see it taking up a proportion of it, or some of it, or?
At the moment, I would say it's quite a small proportion of the market, but it is going to grow. There's definitely potential to increase the amount of biogenic binder sales that we do. But it's about a customer engagement piece and engaging with local authorities and our paid teams to make sure that the message on biogenics is getting out there.
Yeah, but it's just describe. It's a combination of things to end up with the ultimate output of lower carbon, isn't it? It's not just one thing we're doing. You went through a range of products there. We've used the ultimate products in laterally in combination with another recycled product, so you can layer up the benefits if you work together with a supplier.
Yeah, and basically, what we're trying to say, there's a whole toolkit out there. What you pick from that is totally up to yourself. You know, we work with you in early engagement stage and look at the different options and the payoffs versus the, you know, carbon reduction in the long term versus short term. Depends what your drivers are and what you want to do. And I think it takes bravery from like the local authorities to actually say, right, let's do that. And I think that snowball effect will become more, you know, other authorities will adopt that.
Getting away from the 900 and stepping outside of that comfort zone and saying to, you know, somebody like Tarmac, we've got this project. Yeah. What can you bring to the table to help us reduce our carbon, either through initial carbon reduction, or you want to talk to us on a holistic whole life?
Yes, yeah. And that's where we want to get to, as you know, me and Matthew in our roles. That's what we're here for. Come and talk to us. We'll work with you, and it's a great story on both parts. And we find a lot out from trials, don't we?
Yeah. I mean, you're right. It's a two-way street. The client, the ultimate customer's got to have some skin in the game in terms of the change and the risk. Yeah, some of that.
Yeah.
That's what perhaps got to be shared. But I think there's much more of that going on. The point you made about the amount of materials that could potentially be specified. So that, I think, often leads to somebody just falling back on what they've always done.
Yeah.
So I think we just need to, all of us, have a real think about what we can potentially do for now and for the future.
Yeah, this comfort and familiarity. Yeah. And I think, you know, sometimes you just have to, you mentioned the word bravery. Yeah, it's probably not an over-exaggeration that was mentioned in the presentation. Sometimes you do have to be brave to make those decisions, to try something different, do something new. But yeah, I mean, we're there to sort of help you along.
Yeah,
that's the only way we're going to get to net zero, isn't it?
Absolutely.
Doing something different to what we already have.
Yeah, that's the only way we'll do it, to make some change, a bit of innovation, a bit of collaboration.
Yeah.
Thank you very much.
Thank you.
Thank you, everyone.
Thanks.
So.